take out our highlighter, okay? We're going to think of this idea of differences of squares. Because if you multiply by a difference of squares, it squares the first thing, then subtracts, and squares the second thing. Really nice, because that would get rid of any square roots that you have, whether you have one or two. And we have a new definition that most students forget, so we want to really highlight it. Well, there it goes. There's the highlight. This is on page 124. So we call the same binomial with a different sign in the middle a conjugate. A difference of squares is multiplying two conjugates. It's a really weird English word in math. It doesn't come up very often, but if you can remember that when you have a difference of squares, when you have one plus and one minus, those are called conjugates of each other. So if I gave you something like x plus 2y, and I said, what's the conjugate? The conjugate would be the same thing with a different sign, x minus 2y. If I gave you 3 minus b, what's the conjugate? 3 plus b. And whenever we have conjugates and we multiply them together, we always get the difference of squares. So here's our we've had a couple new words for today. We're going to have this new phrase, rationalizing the denominator, which the words in it kind of make sense. The denominator is the bottom. Rationalizing means make sure it's not an irrational number. Square roots are irrational numbers, except when they can simplify. Like square root of 4 isn't an irrational number because it's 2. But square root of 5 is a decimal that goes on forever. So we're going to have to rationalize the denominator by multiplying by the conjugate to get the difference of squares. And if you want to highlight or put a highlighter thing around this box too, maybe. Oh, my computer's slow today. It's like, oh. We'll pretend that's a nice highlighted box around it instead of a black line. So that's the idea of a conjugate. Now when we get to example 4, in A, I have a binomial on the bottom. I have a 3 root 2 minus 4. And I have a 4 plus a 2 root 6. Now, one thing that I did in my head, which you didn't even hear, because it was just quiet in my head, but one thing we always do when we're dealing with square roots is we want things as simplest form to begin with. So I checked every square root that was in this question and said, can I write it as a mixed radical in a more simplified form? No. But it's something we always check, because in the last question we had that square root of 18. And we simplified it first, made our life easier. So you're always looking if there are things you can simplify first. There's not, so now I'm going to have to multiply by the conjugate. So on the bottom, I have a 3 root 2 and a 4, but instead of a minus sign, the conjugate would be the opposite sign. Because that's the only way I would get a difference of squares. Now, when you have a fraction, there's like an invisible set of brackets here, right? And an invisible set of brackets here. So on the top, that's like FOILing. You're going to have to multiply your first ones, your outside ones, your inside multiplied ones and your last ones. So that's a lot of multiplying here. 4 times 3 root 2. 4 times 3 is 12, and I'll have 12 root 2. 4 times 4 plus 16. 2 times 3 is 6. Root 6 times root 2, root 12. And 2 times 4 is 8. Root 6. And on the bottom, it made a difference of squares. That's what a difference of squares looks like when you multiply it out. It's the first one squared minus the last one squared. And we are going to really, really practice all of our mental math skills, because it is so easy to make a mistake if your times table is off, anything like that. Got to be really, really careful. So grade 11 pre-calculus is going to fine-tune all of those mental math skills. Because it's really frustrating when you check the back of the book and your answer is wrong. And most of the time, it's not because you don't understand square roots. It's because you're making little mental math mistakes. So you're going to get a lot better at those. Okay. First of all, we want to simplify this. I can definitely simplify things. Well, that's not what I want. I can definitely simplify the bottom. When I square this, I'm going to get 9 times 2, 18. 4 times 4, 16. Are there any like terms in the top? No. Are there any radicals in the top that you can simplify? Yes. In the top, you see you have a square root of 12? 12 root 2 I can't simplify. 16 I can't simplify. But the 6 root 12, since 12, notice, 12 is 4 times 3. The square root of 4 is a 2, means I can bring a 2 out in front. That 2 will hit the 6, and it will give me 12, and I'll be left with 12 root 3 plus 8 root 6. Now I have 12 root 2 plus 16 plus 12 root 3 plus 8 root 6. And the bottom, 18 minus 6, is 2. The only way we can simplify now, okay, my square roots are all simplified. The last thing I need to check, I'm dividing by 2. Is there something that divides every single thing in the top with the number that's on the bottom? Can you see that everything can be divided by 2? So if everything can be divided by 2, this will now be 6 root 2 plus 8 plus 6 root 3s plus 4 root 6s. No like terms, all radicals are in lowest terms. This is considered as simplified as this question can get. So now, the most complicated word you've learned so far in grade 11 math is the word simplify. Because it's very complicated as far as what you have to do. Lots of things you have to remember to check. So we get to B. I'll rewrite it. I have 2 root 3 minus 4 root 6. First thing I'm doing while I'm even writing it, I'm checking if I can reduce those. I cannot. 3 root 2 plus 2 root 3. 3 root 2s plus 2 root 3s. I have a binomial on the bottom. I checked all my square roots. Nothing simplifies. So, I'm going to have to multiply by the conjugate. The conjugate of the bottom will be 3 root 2 and 2 root 3. And what sign do I need to put in the middle? Positive or negative? Negative, because it has to be the opposite sign to make a difference of squares. we're imagining there's brackets here and brackets here. So on the top, you're going to need to FOIL. And the bottom makes a difference of squares. So I'm going to FOIL the top. 2 times 3, 6. Root 3 times root 2, root 6. 2 times a negative 2, negative 4. Root 3 times root 3. Now, if you have this, and I already wrote the form. Root 3 times root 3 is going to be 9, right? And square root of 9. And the square root of 9 is 3. So maybe I'll just put it in brackets to remind myself, oh, I have 4 times 3. If you saw it right away and wrote minus 12, perfect. But sometimes you're doing steps and you're like, oh, I already wrote the minus 4. And now I see root 3 times root 3, that's going to give me 3. Next, minus 4 times 3, minus 12. Root 6 times root 2, root 12. And minus 4 times minus 2 plus 8. And root 6 times root 3, root 18. All over, and since the bottom made a difference of squares, I would have the first one squared minus the second one squared. So the bottom, I'm going to have to simplify. This is going to be 3 squared is 9, times root 2 squared is root 4, which is 2. 9 times 2, 18. And here we're going to have 4 times 3, minus 12. Are there any square roots on the top that can be reduced further? Can't reduce to root 6. 4 times 3 I can put together, that's minus 12. Can I reduce the root 12? You can reduce root 18. And you can also reduce to 12, because so we're looking for perfect squares. This is where the mental math. 12 is 4 times 3. So if I can pull out the 4, square root of 4 is 2, minus 24 root 3. 18 is 9 times 2, square root of 9 is 3. This will be 24 root 2. The bottom reduces to a 6. And I have 6 root 6 minus 12 minus 24 root 3 plus 24 root 2. Is there anything that divides all of them on the top that also divides the number on the bottom? They all divide by 6. Works so perfectly. That would get rid of the bottom altogether. So if I divide everything by 6, I'm going to get root 6 minus 2 minus 4 root 3 plus 4 root 2. And here's my final answer. In lowest terms, everything simplified. Okay? In order to get to that final answer, we have to be very careful, because you're not allowed to make one little mental math mistake along the way. Take your time. Be careful. Get good at your times table. Because there was some, I was marking your quizzes this morning, there were some times table interesting things happening. Numbers that never existed before. All of a sudden, oh, I know. It's like, uh-oh. What was one of them? Like 3 times 12 is 48 or something like that. Uh-oh. It's not true. So we got to be careful with our mental math. Questions for practice are 10 and the other part of 13. Aye.